Hi guys, sorry I couldn't make it today, but hopefully this will be a close second for you. So today's lesson is 7-7, and it is inverse relations and functions. So I think the best way to show you how to find an inverse of a function is to just show you an example. Okay, so let's do example 1. Let's say that our function is y equals negative 3x plus 1. Okay, so all you're going to do to find an inverse of a function is your first step is going to be to change the x and the y, so switch their positions, and then just solve for the y. Okay, so if we switch the x and the y, this now becomes x is equal to negative 3y plus 1. So once those are switched, now we're going to solve for the y. So algebraically, I want to get rid of what's added and subtracted. So I'm going to subtract the 1. So it gives me x minus 1 is equal to negative 3y. And then next step would be to divide by negative 3. So the inverse is equal to x minus 1 divided by negative 3. So the notation for inverse looks like this. You simply have an exponential negative 1. Okay, so that is just simply the notation for inverse of a function. It doesn't mean that it is y to the negative 1. It is just a notation. Okay, so let's try one more time. Let's do a second example. Number 2. Okay, so let's say our function is f of x is equal to x cubed minus 3. X cubed minus 3. Okay, so what would my first step be? Okay, now wait a second, hold on, I have an f of x. Is that confusing? What is f of x? Okay, that should be the y. Okay, so we're just saying that the f of x is simply the y, so if our first step is to switch the x and the y, I would have x is equal to y cubed minus 3. Okay, so then I go through and I just simply solve this for y. So I'd add 3 to both sides, so that gives me x plus 3 is equal to y cubed. Now how do I get rid of a cube? You cube root both sides. Okay, so my inverse, notice I'm now going to use the notation they started with. The inverse function is the cube root of x plus 3. Okay, so let's go ahead and do one more, make sure we totally got this. Let's say number 3. How about the scenario this time is y is equal to x plus 1 squared. Okay, so what is my first step? First step, switch the x and the y. So x is equal to y plus 1 squared. Okay, what's my first step here? Remember, I want to get rid of parentheses, so how do I get rid of the square? Okay, so I'm going to, there we go. I'm going to square root both sides to get rid of a square. So now I have the square root of x is equal to y plus 1. My next step, subtract the 1. So for this one, my inverse function is the square root of x minus 1. Okay, so this is quite easy to do analytically, I think. They're also going to ask you to do this graphically. Okay, so what I want to do is I want to pull up Wabbit and take a look at what these functions look like, and I want to see if you're able to figure out how you would find a function's inverse just by simply graphing it. Okay, so if I take my calculator and I go and I clear what I got in there and simply start by graphing my initial function. So for question number 1, let's say we're graphing negative 3x plus 1. Okay, and I'm going to graph on here its inverse and see if you can see a relationship between them. Okay, so on this one I have x minus 1, so I have to type the top in parentheses because it is a quantity, divided by negative 3. Make sure you use the negative button, not the minus. That is a different button. Okay, sorry about that. We had some technical difficulties, but I think we're back and running. I want to hit a zoom 6. Okay, so that just gives me a standard 10 by 10 window. Okay, so the first one was the original, and the second one was the inverse. Okay, so can you tell what's happening with this inverse? Okay, so I'm going to take this and kind of draw. Okay, so if you look at this, sorry, I'm just going to erase what I have in my background real quick. Can you see what's happening between the original function and its inverse? Okay, so I'm not sure if you can fully tell at this point just looking at those two functions. So what I'm going to do is I'm going to go ahead and pull up the second example and see if that helps you at all. Okay, so again, on the same graphing window, I'm going to graph the original function, so x cubed minus 3, and its inverse. So this one's going to be the cube root, so I need to hit math number 4 of x plus 3. Alright, so now this is going to add on number 2, so there's the original function, and there is the second one. Okay, so what I'm going to do is I'm going to change this window just slightly, and I'm going to change it so that it's a square window, because right now what we're looking at looks slightly skewed because of the calculator window being skewed. It's longer. You can see that the width of this is slightly longer than the height, so if I hit number 5 it will square it out so that it looks proportionally correct. So let's take a better look at this. I want you to see if you can see what's happening between the original functions and its inverse. Hopefully what you are noticing here is that the functions are being reflected. They're reflections of each other. So do you see the line that they're reflecting over? Okay, so the line that they are reflecting over is the diagonal right through the origin. Okay, so that line, the equation of it is y equals x. Okay, which makes perfect sense because what was the very first thing we did on these? We switched the x and the y. Okay, so if I graph y equals x into this, you can hopefully see a little bit better this line of reflection. Okay, so that's the line that they're being reflected. Okay, so let's see if you can do this with the original function and predict what the inverse function is going to look like. Okay, so I'm going to clear out questions 1 and questions 2 and insert question 3, and I'm just going to start with the original function and see if you can predict what the inverse is going to look like. Okay, so we have the quantity of x plus 1 squared. Okay, so that is a parabola. It has been moved to the left exactly 1 unit. Okay, so can you imagine this parabola being reflected over the y equals x line? Okay, so hopefully what you're going to see is that since this function, the bottom of that parabola crosses right on the x-axis at -1, that -1 intercept is now going to become a y-intercept on the inverse function. So the parabola is going to be kind of tilted on its side and turned like this. You see it? Okay, so let's type in the inverse and see if we're right. Okay, so we have the square root of x in the parenthesis -1. Okay, so here it comes. There's the top. Now wait a second. Now why didn't it graph the bottom half of my parabola? Okay, why would it do that? Okay, and the answer to this is that if I was going to graph the bottom half of this function, would it actually be a function? Okay, and the definition of a function is, does it pass the vertical line test? If I drag my pencil vertically through that function, would it ever cross at more than one place? Okay, and this, if this was a sideways parabola, would not. And the calculator will not graph non-functions. Okay, so what's happening is it's restricting the domain of the function. Okay, so this function is only existing when the x value is greater than 0. Okay, so the piece I want you to really understand about this is the inverse function a function or not? Okay, so think about the way we have this. Number 1 was a linear function. Okay, does a linear function always have an inverse? Yes. Okay, the inverse will always be a function, because if you turn that on its side, it will still be a straight line. If we look at a cubic, okay, a cubic function is a John Travolta, looks like that. Will it always be a function? Okay, sure, as long as it looks like this. But what if my John Travolta looked like this and had lots of waves? Would that inverse be a function? Okay, that would turn sideways and look like this. Would that be a function? Okay, no, that would not be a function. So you got to be careful about what the original function is. Okay. What about parabolas? If you turn a parabola on its side, will it ever be a function? And the answer to that is no. Okay. So that should be enough information to get you started and finished on the assignment for today, which happens to be on page 404, and you have 2 through 28 evens. Okay, so that'll be due at the beginning of class tomorrow or the beginning of the next time I see you.